In the last video you watched, we talked about the different ways we can classify matter. We can classify them as pure substances or mixtures, and within those categories, we can further classify them into elements, compounds, homogeneous, and heterogeneous mixtures. In this video, we're going to look at how homogeneous and heterogeneous mixtures can be further classified into three different categories. And so those three categories are solutions, suspensions, and colloids. So the first one we're going to look at is solutions. So whenever we look at a solution, so an example of a solution would be something like salt water. And so I have some in the test tube here. Appearance-wise, when we're looking at a solution, solutions are clear, they're transparent, and they're homogeneous. So again, it's clear. You can see my hand through it as I move underneath it. It's homogeneous, so you don't see the different parts of this mixture. You can't see where the salt starts, where the water begins, which part's salt, which part's water. It all looks like one thing, one uniform thing. The particle sizes of a solution are super small. And so between solution, suspension, and colloids, these have the smallest particles. They're so small that you can't see them. That's why it looks uniform. It looks like it's just one thing. You honestly can't tell that this is just, you can't tell the difference between this and pure distilled water, for instance. The other thing you need to note about solutions is that solutions don't ever separate over time. So the salt water that I've made, I could keep this out for the next week or month in this sealed test tube, and it's still going to look like this. The salt and the water aren't going to eventually separate. The other thing that we want to pay attention to is when we look at a solution, the solutions don't exhibit the Tyndall effect. And so what the Tyndall effect tells us is the Tyndall effect is the ability to disperse light. And so I have a laser here, and I don't know if it's going to show up well in the video. But basically, if I put a laser through it, you can see that there is no light going through it. So you can see it does go through it, but you don't see it in the solution right there. So it does not exhibit the Tyndall effect. And so we'll see that there are these other mixtures will exhibit the Tyndall effect, and you'll see what I mean in a second. The next category we're going to look at is suspensions. And so suspensions, I have an example of one. A suspension is a type of heterogeneous mixture. And so these are typically cloudy, and they have at least two visible substances. And so the example I have of a suspension is water and oil. And so I have it here in the test tube. I shook it up a little bit, so it's kind of blended right here. But the key thing about the suspension is when it's mixed together, it's cloudy. So you can see that this part right here is cloudy. And you can see that there are at least two different substances. So you can see where the water is starting to separate, and then you also see the cloudy portion where it's all mixed together. Eventually, if we let this sit out, oil and water will separate. And so that's a key thing about suspensions, is that over time, if you let it sit out, they will settle out, they will separate. So you'll see two distinct layers, or however many layers, depending on how many different substances you have in that mixture. With these, the particle sizes are the largest compared to solution and colloids. And so with these, you can actually see the different particles. You can see them with the naked eye. And so, again, with suspensions, the main thing we want to understand is that when mixed, they are cloudy. But as we let it sit out for a while, they will separate, and it will settle out, and you will be able to see the distinct layers of the different parts within that mixture. All right, and then our last one is a colloid. And so a colloid is also a type of heterogeneous mixture. However, these particles, although not uniform, they are so small that it appears to be homogeneous, but is not homogeneous. So an example of that would be something like Jello. So in this test tube, I have some Jello right here. And so these particles are not as large as suspensions, but they're also not as small as solutions. So they're just right in between solutions and suspensions. With this, with colloids, they do not separate over time. So if I keep this test tube for the next week or month or however much longer, it won't eventually separate. They'll still look just like this. And these particles, they are visible if we look under a microscope, but to the naked eye, they appear as if it's homogeneous. And so when we think of a colloid, again, colloids are cloudy, but overall they look uniform and they look homogeneous. However, they are heterogeneous mixtures. And so for this, the Tyndall effect, you should be able to see the Tyndall effect in action here. So again, I don't know if this is going to work well or not. So if it doesn't, make sure you look at the slides posted on Google Classroom, because those will have better images and examples of the Tyndall effect. But here, you should see the lights being dispersed. And you can kind of see it. It's not that great. A better example of the Tyndall effect will be with the suspension. And so here's my suspension. I've mixed it up again. When I put the light through, instead of going straight through, you can see it disperses the light. So you can see how it just spreads out that laser. And I'll show you the solution again, just so you have a side-by-side comparison. So, oops, that's not it. Okay, so our solution, I've got my salt water here and I have my oil and water mixture here. So when I put the laser through, you should see there's a big difference here. So here the light just goes through. So with the solution, the light just goes straight through. And then with my suspension, you can see that it will disperse the light. It'll spread it out. So that's the key difference between your solution, suspension, and colloids. So both your suspensions and your colloids are going to exhibit the Tyndall effect, while your solution is not. So overall, we need to be able to look at different substances and be able to determine if it's a solution, suspension, or colloid. And so in your notes, there is a nice, beautiful chart that summarizes your solution, suspension, and colloids. And so this is it right here. I recommend copying it down or even just making a mental note. You don't need to know the actual particle sizes, like the actual exact measurements, but you do need to know which one's large, which one's small, which one's medium. So again, with your solution, particle size-wise, these are your smallest. And then your suspensions are your largest. So colloids fall somewhere right in the middle of these two. So they're the intermediate in terms of size. But again, you need to be able to recognize what makes a solution, what makes a suspension, and what makes a colloid.